today's session, we will be discussing about some of the advanced database management models. You have already gone through a very strong database management system model, and that is relational database model. Why we should go for advanced database management model when we already have a strong database management model such as relational available to us? Well, that tells us, that indicates to us to find out what are the limitations of relational database management systems, and in turn what is the need for advanced database management models. Well, the need of the database management model can be basically, the first one is that business are not centralized. What do we mean by saying so? Let us take a very simple example of a bank. A banking industry is spread, let us say State Bank of India, it is spread all over India. Now, if it is spread all over India, that simply means that all the branches are maintaining its local data, and if we are talking in terms of a centralized relational database management system, probably we are putting too much of restrictions that the data should be transferred from one site to the headquarters all the time, and the data should be updated all the time at the headquarters instantaneously. Although in the future it is going to be a reality with the high speed network, high bandwidth network being reality in India, but still such kind of a thing may take some time, and probably that is not the right kind of approach to whenever organizations are distributed. So, under those kinds of circumstances, probably we need another model of database management system which may have relational database model as the base, but is something above it. Probably we are talking in terms of distributed database management system. We will talk about that management model a bit later. The engineering design databases such as CAD, CAM databases involve complex objects, and a record of an object evolution, that is object versions, need to be maintained. Now, if we look into these requirements, what we are basically looking into, that object oriented technology should be brought into the paradigm of databases. If that is so, that obviously what we are looking forward to, an advancement over relational database model, and probably we are looking into object oriented database model. What are the other needs? Modern data include variable length text, numbers, images, graphics, and digital audio and video. And another one is artificial intelligence and expert systems represent information as facts and rules, which we call a knowledge base. If these are the needs of any relational database management system, do we expect that a relational database management system will be able to deal with text, variable length text, the graphics in a very systemized manner? Probably not. If that is so, then what do we need? Probably another model for database management system, maybe multimedia databases. We will look into what are the basic requirements for multimedia databases later on. Similarly, for knowledge bases, probably AI related cases, we need to have an advanced model of database management system, and we call it intelligent, basically that is knowledge database management systems or a knowledge base. So, these are some of the basic needs. Are there any other needs, or are there any other limitations? Yes, they may be, but they may not be the direct kind of limitations. Well, those limitations may be the decision support systems require a huge amount of information to be scanned and processed at different locations on the internet. Okay. So, this is one particular area, the distributed organization, but decision support system require lot of that information to be put into one place. Applications may require access to data stored on the web server. Now, these two requirements basically tells us that although the relational database management systems are fine, yet there are new applications or maybe development paradigms where we are looking into concept like web databases, where data is available through web, or we are looking into applications like data mining or data warehousing. Those kinds of applications where data from lots of places is brought under the umbrella of a single unified database, okay, and there you take certain decision or decisions basically based on the data available. Similarly, certain relations, correlations among the data you find from certain decision point of view. So, we would like to look into all these kinds of things, and in addition another paradigm which is called mobility or mobile databases. So, we are going to have a look into some of the basic issues related to all these models. Now, let us begin with the distributed databases. The basic need for distributed databases is that the organizations have distributed structures. Local data is more important than global data, and local queries should be addressed in the shortest possible time. If we are looking forward to these three basic needs, then what we are basically trying to say that distributed database management model probably is the database management model which are looking into the local requirements more effectively than what a centralized database management system would have. If that is what they are doing, then what exactly we are looking into as far as the data is concerned, in distributed databases is concerned. Well, whenever we talk about distributed database management system, we talk about two basic issues or terminologies. Those are data replication and fragmentation. Fine, the concern is local query, yet the local data is available locally, but there are so many sites. So, if there is a global query and a local site is down, probably you will not be able to answer that particular query. So, what do I need to do? Probably since I have so many sites, I evolve a mechanism by which my data is distributed, replicated, same data at various sites. But does that mean I create a complete set of a database, that is all the data is put into one centralized system and that whole data is duplicated at all the sites? Probably that will be very ineffective way of utilizing the facilities. It will put too much pressure on our utilities without giving us appreciable gains. That simply means we should put certain portions of data at various sites depending on the local needs. If that is so, the concept called fragmentation comes into picture. So, what we have talked about is replication, duplication of data, but we do not want to duplicate the complete data. We want to duplicate only relevant data, and that we do with the help of fragmentation. Okay. Now, what are the advantages of replication? First one is availability, robustness, increased parallelism in query processing, and a disadvantage, increased overhead on updates. Now, let us try to understand availability, robustness and increased parallelism in query processing. Availability I have already hinted at. So, one site is down, same data is available at a different site. Your data is available, I can still answer a query. Robustness, automatically this leads to a very reliable, robust system, okay, which is not going to fail easily, reliable system. Increased parallelism. Now, in what way? I have same data available at 4 different sites, and if I am referring to a different portion of database in a particular query, or if I am referring to different tables altogether, all those portions of the queries can be executed in parallel at 4 different sites. So, the chances are that overall query response may increase. Okay. So, this is increased parallelism. Finally, the problem, if you have more replicas of data, the problem may occur as far as updation of data is concerned, but then there are mechanisms by which the data updation is ensured at the site concerned, right. So, what can be those mechanisms? Those mechanisms will be in the form that if some site is down and when it comes back, some sort of consistency is maintained. If the sites are up, no problems, the updates can be propagated, okay, and some sort of responses can be received. Still, it is going to be somewhat more troublesome if your connections are a bit slower, but in the near future, as the things are progressing, definitely things are going to be much faster. Then there are different mechanisms for controlling those kinds of things. Then we look into distributed query processing. The cost of data transmission on network and parallel query evaluation. These are the 2 main issues which are related to distributed query processing. Parallel query evaluation I have already hinted at, that you try to pass on or distribute a particular query to various sites. But what about cost of data transmission? Well, in this particular context, you must have heard about a concept called semi-join operation. The objective of semi-join operation is that it tries to minimize the cost of data transmission. There may be some data which is not available at the site where query has been raised. Now, how exactly data is to be transferred from a site where data is available to this particular site? Is the complete table is to be transferred, or only the data which is needed is to be transferred, right? So, we are concerned in this particular area with the semi-join operation. Now, what an object oriented database system? They should provide facilities of object oriented systems, and they should also provide standard database facilities which are existent in the relational database system. So, what we are looking in object oriented system is basically these 2 things. Well, then how do we implement it? One of the mechanism for implementation may be use persistent programming language, where the query language is fully integrated with host language. That is persistence. So, what you do basically use a programming language, but having a facility for persistence. What is persistence? That the data is stored permanently till it is explicitly removed, which is the nature of basic database management systems, that is relational one. What are the advantages of this particular scheme? Both the host and the query language share the same type system. No explicit change of format for storage of object as data and vice versa, and it is a very powerful programming tool. So, basically what we are trying to say, that we are having same platform for host language as well as query languages, and that helps us, that facilitates as far as answering the queries are concerned. What about the disadvantages? Well, the disadvantages of this scheme are, it is easier to make programming errors that may damage databases, okay, and they are difficult to implement automatically. Some of the things, what are the things which are difficult to implement automatically here? Optimization such as reduced disk input output. Most of you who have done relational database management system will be knowing that one of the way of optimizing the response to a particular query may be to optimize the disk input output, which is the costliest operation as far as time is concerned. Okay. And it is really difficult in a relational database management system, it is quite easy, but with a programming language it is not going to be easy. Okay. What are the other model for object oriented implementation? It is not direct object oriented model, that is called object relational data model. What does object relational data model do? It extends the relational model by providing a richer type system, including object orientation, and add constructs to query language to deal with added data types. So, more types are created for relational system, and how those types are going to be handled through queries, those are also evolved. It supports multi-valued attributes, generalization and specialization to be represented directly. So, you are drifting from relational database management system to a very little extent, but then you are definitely drifting, because multi-valued attributes have no role in true relational database management systems. Similarly, generalization and aggregations. Right. What are the advantages of this? Well, they support complex data types, powerful query languages, because it is built onto the relational model. So, relational query languages are supported here. However, the disadvantages are, in fact, there is one disadvantage, that performance for query is slower than persistent object oriented database systems. So, they are slower, yet they support good mechanisms, older mechanisms, reliable mechanisms which already exist, which have already been perfected, and most of the commercial databases are of this type in today's context. From distributed and object oriented databases, let us try to make movement to client server database management systems. Both distributed and object database management systems can be of client server type. Even relational database management systems can be implemented through client server type. Now, what is this client server? Well, they are based on division of work using a network of computers. So, what do we have there? The server which manages access structures, which may be indexes, query evaluation and optimization, or the queries are executed by the server. Query optimization is once again done by the server. Concurrency control, if concurrent transactions are getting executed, that means many clients can be made functional at the same time, and concurrency control will be taken care at the server side and recovery. In case of any failures, it will be automatically be dealt with by the server, automatically taken care of. On the other hand, what client or the front end will be taken care of? It consists of forms, report writers, graphical user interface. So, these basically distribute the load from the client as well as onto the server. Server is responsible for certain things and clients are responsible for certain things, and there is a load distribution. The basic interface which basically exists between the two is SQL or application program. Now, that is very important. These interfaces definitely will be communicated through the network, but the basic interface between the two is SQL, okay, or applications interface. That is why you might have heard about two layer structures, that is front end, back end. The basic interface being SQL. There is front end, back end, and there is an application server in between. 3-tier architectures, where you have application layer as the intermediate interface layer. Okay. But the backbone still may be the SQL as far as application layer is concerned to the back end. At the top end, it may be just the communication or the open structure like other ODBC kind of structures, that will be at the back end, but other message passing systems can be at the front end. The server systems can have transaction server or query server, to which query can be sent for an action, results are returned to client. Requests specified through SQL or application program or remote procedure call mechanisms, and standards like ODBC or JDBC are the standard requirements for these kinds of systems. The basic server system, that is transaction or query server. Now, is there any other server type? Yes, you have data servers. Now, these types of servers can be used for LANs if client machines are powerful, and most of the client machines in today's networks are. If the tasks are compute intensive or computational intensive, data from server is shipped to client for processing and shipped back. Okay. Server is shipped to the client for processing. So, processing is being done at the client side too. Require full backend functionality at client side. So, you want more powerful clients, only then this kind of a data server will be advantageous. These kinds of data server may be very useful when you have number crunching problems, when you have lot of data to be processed. Under those circumstances, these data servers are of immense importance. So, what we have covered by now, we have talked about the distributed database management system, the object oriented database management system, and one of the implementation mechanism, that is client server database systems. Now, let us look into another paradigm, and that is knowledge based database management system. Now, what is a knowledge based database management system? A system to manipulate and share knowledge is what is the role of knowledge based database management system. Knowledge is represented as facts, rules, heuristics and procedure. Inference control unit defines existing knowledge, and in fact they define as well as refine. What additional features are there for knowledge database management system? Knowledge base is kept separate from inference mechanism to allow refinement without recompilation of inference program. Now, it is a very good mechanism. You have separate inference engine and knowledge base. Inference engine keeps on working onto the knowledge, keeps on producing more knowledge. So, that acts data for inference engine to make certain predictions. Now, how to find new facts or predictions? Okay. In fact, they are not predictions, they are the truths, statements which are produced, or false statements which are produced, that this statement is false or this statement is true. Well, finding new facts can be through deductive reasoning, that is, find new facts out of those logics. Okay. Inductive reasoning, prove base facts, and then that is prove basic fact, and then extend to unknown facts which are unknown, try to prove them with the help of base facts. Abductive reasoning, which generate hypothesis to explain an observation. You assume something, hypothesize, try to prove something, and all these things, all knowledge database management system may be equipped with explanation facility. Why explanation facility? So that you can trace your route to a particular logic. This kind of a mechanism sometimes is very useful in testing knowledge based management systems, whether your created your inference engine is perfectly okay or not. The knowledge database management systems have some more issues with them. Knowledge representation require data structures with rich semantics. Operations in a knowledge base are more complex than in a traditional database. When a rule is added, the system must check for contradiction and redundancy. The complexity of checking increases rapidly with the size of knowledge base. Now, that is a real fact. The most unfortunate thing is, as more and more facts are kept on adding, we keep on adding facts into the knowledge base, the size keeps on increasing, and the checking, consistency checking becomes more and more difficult. Adding a rule becomes more and more problematic. Making inferences becomes more and more problematic. However, that is where our knowledge base structure should be strong enough to look into the changing needs. And now it has come up as a major area of thirst as knowledge based systems. Newer and newer mechanisms are getting evolved. Geographic data. Now, these are spatial in nature. One of the example can be maps. Maps may provide not only location information such as boundaries, but they can also provide boundaries, rivers and roads, but also elevation, soil type, land usage. So, you are making a database not only just a visual, but then lot of information is hidden. Second type of spatial image database can be the satellite images. Now, one of the major issue is how the data is represented in spatial databases. Well, one of the major mechanism is two-dimensional raster data, that is scanned and kept as raster. And in addition, it is difficult to store vector data because it is to be created, and from the complex images it is very difficult to create some logical vector data. Yes, we talk about fractals, excellent, but then they are very difficult and complex mechanisms and difficult to determine into a system. Creation of curves, etc., use advanced data representation model like I told you, but they are not easy and they are extremely complex within themselves. What are the basic application for geographical database management systems? One of them can be vehicle navigation system. In what form? You have suppose various terrains, you have the spatial database, geographic database of a particular area. How vehicles are to be moved, where exactly are the roads clogged, can be utilized. I think recently Delhi government is talking in terms of vehicle navigation system. They need to use this kind of a database management system. Okay. Next, the multimedia database. What are the basic issues over there? Databases that store multimedia data such as images, audio and video. Typically today's RDBMSs store multimedia data outside the database in files. They are harder to provide database functionality such as indexing on the basis of actual multimedia data contents in RDBMSs, and there is always a missing data problem. Some linkages get disturbed and those kinds of problems does occur. What are the issues related to multimedia databases? That they should provide support for large objects, they should provide similarity based retrieval schemes, image similarities. They should provide retrieval of data such as audio and video, which must be delivered at guaranteed steady rate. So, some of the problems which might be, people are trying to solve are once again using vector graphics, trying to convert graphics into some vector data, specific vector data, and that actually you can mix match. So, you require special facilities in multimedia databases. So, what we have covered by now? We have covered distributed databases, object oriented database management systems, knowledge database management system, the needs of geographic and multimedia database management system, and one implementation mechanism, the client server. Now, let us look into some more interesting paradigms for database applications, and one of that is mobility. Mobility is a new dimension in the database management system. I will not say very new, but definitely it is somewhat newer. Laptops and notebooks are available and are in widespread use. Low cost wireless digital communication networks are widely available, and that is why we should provide some support for mobile people. Okay. There is a centralized database and some support for mobile people. What kind of support we can provide and what kind of application we can provide for them? Well, we can have package tracking system. The logistics, packages are moving. You do not know what stage your package is. So, that particular application can be provided through mobile computing. Disaster management. I think there is a specific need for this kind of a mobile database systems. People have to move, keep on providing information, and it really sometimes help in rescue work. Okay. Medical emergencies, once again related to disaster and maybe other medical emergencies. At any point of time it can happen. and there is a mobile medical van which simply the CAT services which are there helps it. Okay. Access information pertaining to new location. So, you have moved to a new location, more information has been made available to you. Okay. So, that can be from the mobile database. You keep constantly moving and getting access, that is it. Issues: no fixed location or network address. Now, that is a major issue. You are moving, so your network address may change because you have moved from one server domain to probably another server domain. Complicates the query as location parameter to that query will change. So, we have to look into this kind of a requirement. For example, nearest hotel and petrol pump may change according, suppose I have made a query and you have made that particular query, let us say when you were moving from Delhi to Alwar, and suppose by that point of time there was a link was down, and by the time you reached Jaipur, the whole information has changed, the context has changed for the query. So, that is one of the major problems. Battery power is a scarce resource for mobile computing. You have very limited battery power, and communication takes lot of battery power. That simply means we should minimize the communication. If we minimize the communication, we are paying on to the other extreme. What we are paying for? We are paying on the account of consistency. Use scheduled data broadcast to reduce the need of queries. For example, stock data. Increasing amount of data may reside on the user machine rather than the administrator. So, this is how you will reduce the load onto the battery through communication. What are the basic components of mobile computing system? The mobile host through which you will go do the communication. Wired network of computers which is providing the backbone, and mobile support station as per geography. So, there has to be certain mobile station to which your mobile host should be able to communicate. Route between the two mobile hosts may change, thus dynamically changing the communication cost. That is one of the problem which we have already pointed out. Some of the comments about the mobile computing may be that query may be answered by catching broadcast data. This will reduce load onto your communication cost. Mobile host may remain disconnected for a long time. The issue are recoverability and data consistency. So, there should be more provisions, strong provisions for covering these kinds of issues because of inherent nature that they are disconnected. So, as soon as after let us say stock data may be getting broadcast after let us say a gap of 10 to 15 minutes, it might not create that many major problems as far as inconsistency is concerned. So, I mean we never know the type of application in this particular case. However, those applications where this kind of a need is not so critical, constant updation need is not so critical, can easily be put into mobile computing paradigm. From mobile computing, let us move on to another domain called data mining. Large data is available. You want to put some data into place. Data mining is defined as finding relevant information or discovering knowledge from lots of data, from a large volume of data. It attempts to discover statistical rules and patterns automatically from data, different from machine learning as it deals with large volumes of data stored primarily on disks. Okay, that is one of the major differences between the two. What are the classes of data mining problems? Well, the very first class of data mining problem is called classification. What is classification? Finding rules that partition the given data into disjoint groups. For example, to find credit card worthiness, factors such as actual payment history can be considered and rules can be described for calculation. Similar needs exist for loan approval, setting insurance premium, stocking of particular item, etc. So, this is classifying, okay, classifying on certain historical criteria. Second one is associations between different items. What do you do in associations? The example for association can be someone who buys bread is likely to buy milk. Now, that association has been determined after looking into a database of a particular company. Okay. Now, how does this particular association helps? Well, a shop may place bread near to milk, okay, that will help the customer, they will pick up both simultaneously. A shop offering discount on bread may not offer discount on milk, or maybe instead of offering to increase its sales, instead of offering discount on bread, what they may do, which all the people can do, these people will offer discount on milk in the ratio of the discount which is expected on discount on bread. In turn, increasing the sale, I mean, it is really difficult to offer discount on milk, which is a very consumable item and where the margins are very, very low. But then by doing so, you increase your basically the sales potential, and actually you are compensating for the bread. So, something of that kind, your compensation is coming from discount on the bread. So, that is the kind of business tricks which people play on the basis of this kind of a data. Sequence correlation may also be utilized to extract useful rules and knowledge, which can be utilized in doing certain sequencing operation, certain system structurings. It really helps over the lifespan of an organization. User guided data mining. Now, that is something, a mechanism of data mining. Users have the responsibility of discovering the rules. Database system plays supporting role. You may make hypotheses and test them on database. Data visualization system, clients groups allow compact meaningful data representation to users. Now, the basic objective of user guided data mining is that user is the master and he mines through the data and makes certain rules, heuristics, certain assumptions and come up with certain rules. Whereas, the automatic discovery of rules is also possible using AI techniques. The automatic discovery of rules is possible through it is influenced strongly by artificial intelligence. Large volume of data is handled efficiently using various efficient access methods. So, the advancement in computer science and artificial intelligence actually had led to automatic discovery of rules and this kind of a thing. Data warehouse, the problem. Many companies have presence over numerous sites. Each site may generate a large volume of data. For example, a large retail chain. Large organization may have complex structure. Different data may be present at different locations and you would like to access only part of it. For example, manufacturing data may be available at the plant, customer complaint may be available at customer service center, and maybe at sales office some sales data is available. Corporate decision maker require access to information from all such sources. So, you have huge amount of data in a corporate available, and that huge data is to be utilized, but only portions of that data, not all of the data is of our concern. And maybe some more problems. Setting up queries on individual sources is both cumbersome and inefficient, and sources of data may have only current data while decision maker need older data. So, all these problems, all these necessities tells us that we need to have some centralized or distributed place where decision makers data is kept in a very cohesive fashion, so that the decisions relating to a particular organization can be made. What do you need for it? The data warehouse. What is a data warehouse then? A repository of or an archive of information gathered from multiple sources, stored under a unified schema at a single site. The data once gathered are stored for longer time, permitting access to historical data. But will you store all the data in a data warehouse? Probably not. In fact, never. If you store all the data, then probably you are once again wasting your resources. Let us extend the data warehouse. What is data warehouse? Single consolidated interface to data. The transaction system is not burdened with the load of decision support system. This is one of the major advantages of keeping a data warehouse. Your transaction system is separate, your warehouse decision support system is separately kept. It is sort of useful thing also for managers, because they get all the data, they get privacy of their data, they make certain influences out of that data, and they keep it quite secretive. Although normally this kind of information is not to be kept secret, but then that is somehow the nature of the data. Data warehouse. What kind of structure we have? We have data sources. From there we get data into data warehouse, and the components are data loaders and the database management system. And finally, we have query and analysis tools, which are used by the decision maker for decisions, for some decision support system. When and how to get the data in a data warehouse? Well, there are certain architectures which are called source driven architecture, where continually or periodically data is updated. Second one is called destination driven architecture. Periodic requests are made for new data to sources. So, you make requests, and generally data warehouse have slightly out of date data. Now, that is a common thing. After all, you are collecting data. So, you might not be collecting the whole data all the time, and since it is required for decision making, probably at that point of time you would like to update it whenever you want to make a particular decision, or maybe some out of data is acceptable, because decision making process itself is based on certain heuristics. So, some amount of tolerance in data is acceptable. Okay. Now, what schema to use for data warehouse? Data sources may have different schema or data model. Schema integration may be needed. The data stored at warehouse is not just a copy of data at sources. You got to you got to create certain reduced data, and definitely you got to modify the original schema. There is lot of differences among the schema at various sources. Okay. So, how to propagate updates in this particular case? Same what you do for views. If relation are same, then okay, else the problem is same as updating of views. So, this is nothing new what we have. What data to summarize? Aggregated view of data is preferred. Since you are dealing with data warehouse, you would like which is to be utilized into a decision support system. That is why normally an aggregated view of data is a preferred view. Web database systems. So, from data warehouse, let us move to web database system. The access to web database is not performed using instructions typed at a command line or custom design interfaces, but is done using HTML based web interfaces. So, basically you have client server architecture, but you have a thin client. You might imbibe an application server in between, but web at the back end, or the web server at the back end. The web database systems, web servers are accessed through server side program. Web clients are developed using HTML. Applications can be designed solely for querying a database and returning specific information. This is precisely what I was trying to say. So, you can have a 2-tier or a 3-tier architecture. However, it does not mean that your application server and web server must reside on separate machine. Sometimes they may reside onto the same machine also. Now, how do we put it in definition? What is the basic definition? The ability to integrate a database into applications that can be accessed by user using a web browser is what makes a database web databases. So, this is the basic definition, but why do we need web databases? Well, it helps in better management of large document based information repository to internal as well as external users. Maintenance of customer, supplier and other related information at a shareable information. To certain extent, reasons are the same as why you create in an intranet. Okay. However, over here you are making your facilities, your database facilities available to external agencies also. Why web? Technical product information dissemination. Normally you do this kind of a thing to outside world, advertising. Site access data. So, whenever you want to find out about site access, you can create site access data using a web database. Inventory information for an online store. Now, these are some of the common applications which you find for a web database system. But one of the major critical issue in a web database system is the database security, and the database security basically is dependent on database management system itself, whether it allows files to be accessed and so on and so forth. It also is dependent on interface between a web server and application, which may be used for control. There may be firewalls, there may be pretty good privacy, those kinds of security mechanisms which can be utilized for database security, right. So, with this we come to an end to this particular session. In this session we have discussed about various models, including object oriented model, the knowledge based database model, the distributed database model. In addition, we discussed about multimedia databases, geographic databases, the data mining concepts, data warehousing concepts, web database concepts, and client server databases.